Kia ora Year 12 and Year 11. I'm going to do a quick video for Luke Jones on functions, completing the square and finding the maximum. And yet again, there's really loud piano in the background, so hopefully there will just be piano and not comments about the piano. So let's start off with having a look at the question. I'm not going to do all of it, Luke. I'm just going to do the bit you wanted. We're given a function, and it's a really simple linear function. And we're asked, first of all, to sketch in a diagram the graphs of y equals f of x and y equals f inverse of x. Right, so you should know that one of those, I will just do it actually. So the first function is 3x minus 2, right? So 3x minus 2 looks like this. And the inverse of that function is going to be the reflection through the line y equals x, right? So the way we do the inverse is we swap the x and y. We're going to get x equals 3y minus 2, x plus 2 divided by 3 equals y. Okay, and so that's going to go like this. Let me use a different colour pen. So obviously your picture will not be as terrible as this, but it's going to go like this, right? The point of invariance is the point on the reflection line, which is y equals x. So that's the first bit. Now the next bit, we're given a function g of x, also defined for all real numbers. And this is the bit that Luke wanted me to go over. So express this in terms of x, g of f of x in terms of x, and hence show that the maximum value of g of f of x is 9. Now there are two ways to show that something's a maximum. By far the easiest in this case is to differentiate and set the derivative equal to 0, solve for x, and then go back in and get the value of the function. But we can always do completing the square to find a maximum when I've got a quadratic function. So let's get going and do that second part. I'm not going to do the rest. So f of x, okay guys, we've got the guitar starting up now. The piano appears to have finished. So there's f of x and there's g of x. So g of x is 6x minus x squared. Right, so we have to find the composite function g of f of x. So we're taking f of x and we're shoving it into g of x. So it's 6 times 3x minus 2 minus 3x minus 2 all squared. So we've got a wee bit of algebra to do. We've got 18x minus 12 minus 9x squared minus 2 lots of this, so 12x plus 4. Let's clean that up and see what we've got. We've got 18x minus 12 minus 9x squared plus 12x, take away 4. So that equals negative 9x squared plus 30x minus 16. So that's the composite function that we have to find the maximum for. So what we want to do is to differentiate this with respect to x, right? It doesn't matter that that's not y. It's the same idea that to find a maximum, we need to have the derivative equal to 0. So differentiating this will give me negative 18x plus 30, and that equals 0 for a max. So we get 30 equals 18x. X is equal to 30 over 18. We can divide both of those through by 6, so we get x equals 5/3. So we take x equals 5/3, and now we substitute it back into my expression for g of f of x. Now I can do that in two places, but I might as well do it into my expanded form here. So let's get on with it. We get g of f of 5/3 is equal to negative 9 times 5/3 squared plus 30 times 5/3, take away 16. Now that gives me negative 9 times 25 over 9 plus 50, take away 16, leaving me with negative 25 plus 50, take away 16, which equals 9 as required. So this method was, I think, pretty straightforward because we should all be good at differentiating by this point in the year, right? So we know how to differentiate. It's an easy function to differentiate, and it's easy to get the x value. It's then tedious but easy, relatively, to get the y value. Let's now do it the other way, which is to go back to this function here, right? So this is what we've got for the composite function, and we're going to do completing the square on it. So I'm going to show you two ways to complete the square when I've got a coefficient that's not 1. Right, so we want to complete the square on g of f of x which is negative 9x squared plus 30x, take away 16. Now, I never like working with a negative number here, so we're going to take that out the front. We're going to have negative 9x squared minus 30x, and leave the minus 16 sitting there. So this is basically the method that I did in the revision sessions, where I put a box around those first two terms. The only thing I've done differently is to take out that negative sign. Now, this is okay because 9 is a squared number. So my next step is going to be to go like this. We're going to go, where's my pen gone? Hang on. Negative. Put down your two brackets. Well, the square root of 9x squared is going to be 3x. So we're going to have 3x here and 3x here. Now that means that we don't want to halve this. First we have to think about that what we've got here is going to get times by 3. So we want to divide that in our heads by 3 and we're going to get 10. And we're just going to do a bit of guess and check to see if this works. Half of 10 is 5. So let's try this, minus 5 minus 5. Have we matched up this bit here? Well, look, we've got 9x squared minus 15x minus 15x, so that's looking good. But now we've also got plus 25. We have to undo that. But the plus 25 has been multiplied by this negative. So what we've done kind of by accident by completing the square is we've taken out 25. So we have to put it back in, right? It's just like we did with the easy completing the squares, but we've got negatives and funny coefficients to work with. So my completing the square form looks like this. G of f of x is equal to negative 3x minus 5 squared plus 9. So this will be at a minimum, this will be a maximum when this is equal to 0. So when 3x minus 5 equals 0, x equals 5/3, right? So that's just like when we differentiated. And it will be a maximum with a value of 9 because this will equal 0. So when x is equal to 5/3, g of f of x is equal to negative 0 squared plus 9, which equals 9. So there you go, Luke. There's two ways to do that question. Completing the square, which is actually pretty hideous in this case. It's fine if you've got time to go slowly, but if you're feeling a bit stressed out, the chances that you muck up a completing the square like that are reasonably high. So I would definitely have done this one if I was sitting the exam by differentiating and then solving from there. Right, let me know if you guys have got any more questions on that one. I'm happy to do some work solutions or emails if I have to. Thanks for watching.